Hi there once again, and welcome to another Expresso mechanic tutorial. And in this one we're going to be producing what you see on the screen, which I'm referring to as an object morph. It works in a similar way to morphing the points of a geometric object, except that we're using a bunch of cubes, at least on this occasion. We could use any objects we choose to. And in order to achieve this, we're going to be using a combination of Expresso. I've also added some dynamics because you can see that the cubes do actually collide with each other as they travel along their various paths. And just for fun, I've also put a tracer in there. And we'll also be taking a quick look at Redshift as well in order to render the splines that the tracer produces. That's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We start by bringing in a cube. We'll make it 20 by 20 by 20 and add a 0.5 fillet on it. Purely optional, of course, you don't have to do that. We'll then hold down the Option key and drop this into a cloner. We want the count to actually be 3 by 3 by 3, and our sizes 21, 21 and 21. And that gives us a starting cube. We don't want that actually, we want to randomize things, so we'll bring in a random effector. And straight away it starts to work because the cloner was selected, so we've added the random effector to the cloner. In our parameters, we can start to work in here. We'll set our sizes to 100 each, so 100, 100, 100, just to space things out, and we can see that none of the cubes are actually touching, which is what I want. We will use rotation, and we'll just say 180 in all of these. And that just randomizes things quite nicely. So we've got our cubes set up in their starting positions. Now, if we're going to morph these cubes from A to B, we need, well, basically 2 sets of nulls. So the first thing that we can do is bring a null into the scene, and then in our tools, duplicate this null. And we want 26 copies because of course we've got the first one and we need 27 nulls overall. And we can just hit apply and we've got our nulls in there. We'll call this start positions. And we've got our start nulls. Now, what I'm going to do is select all of these, bring another null into the scene and just call it originals. Select all of these and drop them in here, and I'm going to make them disappear. And then it will be a simple case of just copying these back out. Now the random effector we no longer actually need, so we can get rid of that. Oops, no, perhaps we do need it. We do need it at the moment because I've missed a step. What I need to do is hit C. And now I've just got a bunch of cubes. Now we can lose the random effector. Right, great. So we're set there. Now we need to give all of the positions and rotation values of these cubes to each of our start position nulls. And in order to do that, we're going to be reaching for Expresso. So we'll bring a null into the scene, call it Expresso, and we'll just spell that correctly, Expresso, and then give it the programming tag Expresso. We've got the editor open and we're ready to start work. The first node that we need to reach for will be an iteration. So we'll come down to iterator, iteration, and we've got it there, and we can set its end to 26 because we know that we've got 27 elements to work with. We then need 2 linked lists, so we'll bring one in, place it here, drag another one, command drag another one to copy, and we've got our 2 linked lists, and we can just plumb the output of the iteration into the index inputs of both of our linked lists. We then need to bring in a cube, so where we've got cloner here, this is our cubes. I'm going to rename that cubes actually. that will be better. If we just bring in cube 0, that's perfectly good, and we can give it an object port at the input. At the output, I'm going to give it global position and rotation. And that gets that set the way it needs to be. Moving on from here, we need to populate our linked lists. So our first linked list at the top, we know that we need the cubes for. So let's select all of the cubes and click on one of them, and we've got the linked list populated. Our bottom linked list, we need our start positions nulls. So once again, we'll select all of those, click on the bottom one, and we've got them all populated and ready to go. Moving on from here, we'll just bring in our first null. Again, give it an object port so that we're passing our nulls in sequence to it. And then we can add position and rotation ports. And rotation. That's great, and we'll just move those around. And then all we need to do is connect the outputs from our cube accordingly. Okay, so that should now be doing its job. We can't really see that it is because we can't see our nulls. So what I'm going to do is select all of them and change them from dots to circles and make the circles 15. And now we can see them, and if we just click on the Z, we can see that they're all rotated correctly and positioned correctly. Fantastic. Moving on from here, we need to set up an end state for this. And in order to do that, once again, what we'll do, we'll just take a copy of our cube, just bring it up to the top for now, close the cubes up, we'll just drop it down here. And then what we'll do is drop this into a cloner. So holding down the Option key once again, select cloner. We've got it there. What we'll do with this particular cloner though is change its mode from grid to radial. We'll also make it in the XY axis, or XY plane I should say. And then we can move it into position. Let's have a look, see where we are. Right, at the moment it's not correct. What we need to do, I think, is probably zero out this cube and then do that again. Let's just zero this out. We'll zero it out completely actually. The easiest thing to do. Take it to there and then zero this out. Okay, that's fine. Just what I'll do, I think, is lose the cloner and then do it again. If we just drop that into a cloner now. There we go, that's better. And then we can set it up. So our object needs to be radial, XY, and we'll then move it into position. That's better, we've got it right now. The count needs to be 27, and we'll make the radius 100. And we've got it set up, and I think that's fine. We'll just leave it where it is. That looks good. The next step, once again, I'm going to command drag this into the originals so that we've got it there in case we do anything wrong. And that's all good. It is only a precaution, and I've just realized I took the original the other cloner that we had in there. I've just taken that away. I thought of the command drag to copy it, but I obviously didn't. Doesn't matter because I know that these are all set up fine anyway. Okay, let's move on from here then and think about where we're going next. Well, obviously we've got to produce a second set of nulls. So let's start doing that. So if we click on a null, bring one into the scene, it will be exactly the same as we did before. Use the duplicate, it's already set up. So we'll do that. Drop this null into our copies and call this end positions. Okay, so they're ready to go. Let's go back to the Expresso. In fact, what we'll do first, let's do a little bit of rearranging so that things are tidier. Let's just drop this under there. Close the originals up. Just drop this here. And then we've got our end positions. Now that our Expresso here, what we'll do is actually uncheck enable because we don't want any mishaps. Open it up again and we're ready to go. We know that we've got cubes here. Now what we need is to actually make this second cloner. This needs to be made editable. So we'll hit C and we've got it there and we're ready with our new cubes. Fantastic. So we'll populate this top linked list with those cubes. Let's remove these. Do the same as we did before. Select all of the cubes and populate that list. That's ready to go. And then we need our end position nulls in here. So we'll remove all of these and then open those up and populate our linked list with them. And that's all good. Fantastic. So the next thing we can do then is, once again, in fact, what I'll do is select all of the nulls and we'll make those circles as well. Let's go into our shape, make that circle, make that 15, and we'll make that Z as well so that we orientate them correctly. Okay, great. Let's see if it works. So enable the expression and straight away we can see that all of those circles have jumped to the correct positions. Fantastic. So that's now done its job. We can switch this expression off and we won't need to use it again. It's simply a helper expression. But that's where Expresso can be useful for you. You can use it as a helper occasionally. Okay, great. So we've got that done. Now the only thing we could do again with the nulls here, if we wish to, we could change their color to make them more visible. I did do that in my original setup, so I might as well do it here. Go into our basic here, automatic. I'll make these yellow, close that one up, and our start positions, select all of those, and I'm going to make those green. So that's fine. And now they show up a lot more, and that's nice. Fantastic. So we've got it that far and we're ready to go to the next step. And that will be to actually produce the algorithm in Expresso that will actually move our cubes and rotate them into these final positions. Before we do that, this second cloner we no longer need now. So we can delete that completely. And we just need these nulls. Right, so let's think about doing a little bit more Expresso. We'll close this down, add another Expresso tag, and we're ready to have another go. Once again, we need an iteration, so we'll bring one of those in, and it's set the same, so 26 for its iteration end. We then need, on this occasion, 3 linked lists. So let's bring one of those in, drop it up here, just view 100%, just make things a little bit smaller, and then we can command drag to copy, and we've got 3 of those, and we can plumb the output of the iteration into all 3 index input ports. Fantastic. Let's think about populating these lists. The top one needs our start position nulls. So we'll start with that one. Select all of those and populate them. Let's just go back into there. That's got all of those. Just double check to make sure I haven't got anything I don't need. Second linked list, we know we want our end position nulls. And let's grab a hold of those. We don't want end positions in there, so just take that out. That's fantastic. And then finally we need our cubes. And let's open those up and grab a hold of them. And we've got everything populated. Moving on from here, we need 2 range mappers. So let's bring those in. Got our first one. Now, our data type, we won't be using real on this occasion, we'll be using vector. And that changes everything down here, but don't worry about that, we'll sort it out. I also need output lower and output upper at the input stages, and then I can command drag to copy so that I've got 2 of those. And that should be fine. Now the only other thing we could do is work with the splines. We could put an ease in out curve in there. We might as well just put that in for something extra, and we'll just twirl this open and we'll see what we've got here. We'll make that minus 0.25, and that should match what we've got there, and it does. So yeah, we'll leave that in there because it's quite nice to have an ease in, ease out curve. But everything else is set up okay. Now we'll just move these out of the way because we do need to place a null here, give it an object port at the input stage. We'll take one from the start positions and we'll take one from the end. So I'll take the null 0 from the end so that we've got a distinction between them. I don't think it really matters, but just for the sake of it. Okay, so we've got those in there. We can still move these over a little bit further because we've got to put output stages on both of our nulls. And on this occasion, I'm going to be using global position and global rotation. I don't think it really makes a lot of difference with the rotation, but I'm going to do it anyway. So let's just do that. Get those 2 set up. Great, okay. Now we can wire up our nulls to our range mappers. Now the top range mapper is going to be dealing with global position. So we want our start to go in the output lower and our end here in the output upper, and the same applies to the rotations. So start with that one and finish up with this one. And those are wired up correctly. Now we need to deal with the input values, and in order to do that we need some user data. So we'll select our Expresso null, come down to user data, add user data, and I'm going to name this morph. It will be a float data type. The interface will make a float slider, a real value, and the step 0.01, and our limit max will be 1. So we're going from 0 to 1, and we can clamp the values. And that's as much as we need to do in there, and we can hit OK. We'll just leave it as user data. It doesn't really matter. We've only got one control. The next thing to do, we've got our linked list with our cubes in it. We need to bring in one of our cubes. So we'll bring in cube 0. Just place it here. Give it an object port, and then we can add the 2 ports that we're going to use. And again, I'm going to use global position and global rotation. So I've got those 2 in, and I can just rearrange accordingly. And then all we need to do is drop this into here and this into here. And then we can think about bringing the Expresso null in, grabbing its user data, so morph, and then we can connect this up to the inputs of our range mappers. Right, now that should complete the expression. Well, in fact, it does complete the expression, but we can now check to see if we've got things working. Now, at the moment, I know we won't be working because in our range mappers, we've got to do a little bit more work. If we try to move something now, it just won't happen. We've got to set this input upper, and we've got vector values. All we need to do is set these zeros all to 1. Because we know that our input range from the morph here is 0 to 1. And that's exactly what we're doing here. Okay, now that should allow us to do what we need to do. So let's select the Expresso, and let's see what happens when we do this. Straight away, look at that. They morph beautifully from A to B. Fantastic. Now at the moment they will collide with each other. You can see that they're going through each other. Now you probably won't want that, which is why I added the dynamics. So what we'll do next is actually do that. We'll get the dynamics in and we'll get that working. Right, let's begin. Let's see if we can select all of these and add a simulation tag, rigid body, and we've got all of those in there. Now in the collision tab here, we'll change the bounciness to 0.2, and that's the only change I'm going to make in there. Dynamics, everything is fine. They start immediately. That's great. That's fine. We can leave that as it is. The forces tab here, follow position, we'll set to 30 and follow rotation to 40. I found that they were the sweet spot for this. Right, let's see what happens now when we move. What we'll do, we'll record this at 0, come through to 90 frames and record at 100, or 1 really, because it's 0 to 1. So 100%, but 0 to 1. And then we'll just make the frames here 150. And let's see what happens. And we can see that they are colliding, and then they come to a stop perfectly. So that's the dynamics. It's really simple, but it just makes the difference. Moving on from here, we'll select all of the cubes once again, and we'll bring in a tracer. And we've got our cubes in the trace link because we'd selected them. We'll just bring this down. Let's just move, take that out of there. The cubes, just close them up, put this down here. Okay, let's have a look and see what we've got here. We don't want to trace vertices. We will say from end in the limit, and we'll make this about 40. You can set this up however you like. Let's see what happens now. And we're getting splines trailing behind them. Yeah, I think that'll do nicely for the tracer. We don't really need to do anything else, but as I say, you can set this up to your own taste or just not use it at all. It's entirely up to you. I've just put it in there as a little bonus feature. The next thing that we can do is go into our textures here and bring a new texture in. Now, if you want to render the actual splines that are created by the tracer, there's a very simple way to do it. Now, I thought at first that we would need to use the principled hair. I thought we'd have to reach for that, but no, we don't need to at all. If we double click on here, all we need to add is a single node, or possibly two, depending on what you want to do. But let's just go into our search field here, and we need to do a search for vertex attribute. That's the node that we want. So vertex attribute, bring that in. Just place it here and plumb the color output into the color input. And we can see that that's changed to pink, and because our default color is pink. We'll leave it at that and just see what happens. If we just run the sequence and then we just take a quick render. Let's just do that, just render in the viewport. See what we're getting. Right, we're not getting anything at the moment because I didn't put it on the tracer, did I? So we've dropped that on there. Let's just render that now. It does help if you put it on the tracer, but we're still not getting it. Okay, well, why might that be? Well, the simple reason is that we need to also add a tag to our object. So we need to add a render tag, and it's the RS object. We need that, and we can see that we've got this curve in here. Now, you only get that when this is being used. If that wasn't being used, we wouldn't have a curve option, but we do. And what we can do is in our mode, we can say that we want any of these, but we'll say cylinders for what it is, and we'll leave this where it is. And now if we render, we can see that we do get our splines rendered. So that's a fantastic feature of Redshift. Now, there is something else. I did mention that you can use two nodes. If we bring in a ramp, let's just bring one of those in. We can drop this in here. Now, in our vertex attribute, we've got attribute name, and we've got some presets here, curves. Now, if we say curve ID number or ID color, we'll place that in there, and then we can plumb this into general inputs and its alternative input, alt input. Plumb that into there, and then we can plumb this into our colors or into our color. But what we'll do actually is take that out of there and we'll plumb it into our emission color, and we'll make this an emissive material, which will be much nicer, I think. So let's just work with this. We can take our base color away, we can take our reflection weight right down, and in our emission we can make this, well, I'll make it 10 so that we get quite a nice bright sort of emission, and then we can see what we get now. Let's just render that. Okay, well, we're getting grayscale images, and the reason for that is because we need to work with our ramp, because at the moment it is set to grayscale. So we can load a preset. We'll choose any one, really, it doesn't matter. We'll just go for the full colors for what it is. Double click on there, bring that in, and then we can render this and see if we get something different, and we should do now. And we do. We can see that we're getting multiple colors. Okay, so that's how you go about rendering the splines and working with different colors should you wish to. Really, really simple, just the vertex attribute and the ramp should you want it. If you don't, and you want them all the same color, forget the ramp. But that's a really nice, simple setup for doing that, so you don't even have to go near the principled hair. Great. So we've got just about everything done. Now, there's one last thought. I mean, suppose we didn't want, let's have a look and see where we are. Suppose we didn't want the dynamics and we wanted to do things a slightly different way. Let's just disable all of these. If we go into here and just switch them off, we'll just leave them there. We could actually work with the scale of the cubes if we so wished. We could actually make them much smaller, keep them small until they're starting to spread out and get away from each other, and then make them bigger at the last possible moment. Now let's see if we can do that. So in order to do it, we would definitely need to add a scale into our transitions. So as transform, we can just come down to here and say scale, bring that in. It will be driven by this morph, but what I suggest is to bring in another range mapper because it will give you more control. So if we come down to range mapper, bring one of those in. We can plumb this into here and then set up our range. Now, our input range we can leave as 0 to 1 because that's fine for the morph. But our output range, if we say 0.1 or even 0.01, but we'll say 0.1, don't start from 0, because if you make these cubes 0, they literally just disappear, and then when you try to rescale them, you can't. So, and we can say our output lower is 1. Okay, that's fine. If we plumb that into there, we can see now that we've got tiny cubes. And if we run the sequence, we can see that they gradually scale up to their full size as we need them to. But what we can do, because we've used a range mapper, is use the curve down here. We can use this spline. And if we were to do something like this, and that needs to be somewhere there, let's see what we get now. Yeah, now that might work quite nicely because they wouldn't collide with each other because they'll start off small and we'll get the lines and we'll get them at the tips. And that's quite a nice effect in itself, isn't it, when you look at that? Yeah, I mean, that works really nicely. So that's another alternative if you don't want to use dynamics to make them collide with each other. The final thing you might do, bring a camera in and we'll zero the camera out. And then we can place it in the scene. So our camera's in. All we've got to do is just move it forward so that it, if we just look through it, let's just see where we are. Okay, we want to go a little bit further back so that we get this in the frame. So let's just go into our top view, so F2, and just move this if we can. Just move it backwards. Get a hold of it if it will let me. It won't. Quite know why that's doing that. Let's just redraw everything if it will. That's better. Okay, so we have moved a little bit, and we've essentially got it framed, haven't we? I mean, you can always play around with that, but we'll leave it at that. Now let's just see what happens when we run the sequence. And yeah, you can see that that looks quite nice through the camera, doesn't it? Yeah, nice looking effect. But anyway, that just about brings us to the end of this tutorial, because I've shown you everything that I wanted to show you in this one. And as always, I really hope this has inspired you and given you some ideas for things that you may be able to incorporate in your own projects. And if you have enjoyed the video, please give it a like, and if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one, so I'll see you very soon on the next tutorial.